What I want to talk about is the weird, poor ability of a lot of large language models to do mathematics. And in some cases, even today, they still can't even multiply two four-digit numbers together. You can simply put in a four-digit decimal whole number times another four-digit decimal number, and it gets it wrong. Okay, and I'm not entirely sure I know what people's explanations are, but I don't know that those are accurate explanations. I mean, they might be. I don't know. Um, but I find it hard to believe that it has to be that way, and I find it hard to believe that the people who create these things, I don't know why they don't think it's important for a large language model to also be able to be good at math. And I hate it when people are dismissive about this and say, "Well, if you want to do math, just pull up a spreadsheet or pull up a calculator. There's no need to have your large language model be able to do math well." That's a bunch of malarkey. Okay, it's less productive to have to switch around between a spreadsheet and a calculator and a large language model if you can incorporate the abilities into the large language model. It's counterproductive to have something that will give you a wrong answer. I mean, it'd be one thing if it said, "Look, I'm not a calculator, so I'm not going to answer your question," which still would not make sense. But it's another for it to give you a completely wrong answer. And many of the answers actually look like they could be accurate answers, and some of them don't. That is counterproductive. I don't know if this is done on purpose. Okay, now somebody might say, "Well, you don't understand. It's a large language model. It's doing text prediction." Yes, I do understand. Okay, but when we put together computer programs, you can put together more than one module. Not everything has to pass straight through and only through a general purpose neural network. You can, in fact, put up a front end module where if you ask, starting with this, if you ask a question or if you put in a query that has no semantic ambiguity to it, but it's a complex math problem, okay, it should go straight through the math front end math module and never even reach the neural network and spit out the answer without ever touching the neural network. Okay, certainly if I say, what is 4,229 times 1,362, that doesn't have to ever reach the neural network. And when I hear about how computationally expensive and intense these things are, oh, it's so intensive, computationally intensive to run large language models. It costs so much money. We have large models that create lifelike videos from a text prompt being performed by a neural network, not a collection of heuristic algorithms. And of course, pictures, which take less time, and also complex queries, like you ask it to create a story or a poem or whatever, right? And especially a year or two ago, but even now, oh, it takes so much energy. It takes so much energy. We might have a greenhouse gas catastrophe in our planet. We might overheat the earth. We might, be contributing to too many greenhouse gases and contributing dangerously to climate change just because we're trying to power all the AI. It takes so much energy to power artificial intelligence. Oh, yeah. That, we might be contributing to too many greenhouse gases, right? Does anybody remember a 486? I remember a 486. Thousands of times less powerful than today's modern desktop computers. A modern desktop computer of reasonable power is at least several thousand times faster than a 486. But I remember the 8086. Okay, I remember writing computer programs. I remember writing cartoon graphics programs. Okay, which at one time was impressive. Okay, I remember having a computer program create unique, original, not not how should I put it? It would create brick houses, and you know how like bricks can have like chips. The brick can be chipped, and so it exposes a more pinkish color in the red of the normal brick. If you chip a red brick, it'll like have a little bit of pink color inside the interior of the brick. Anyway, I got it so that it would have randomly chipped areas of the brick. I would create a brick house, and I wrote an algorithm that did that in like a little over a second or something like that on an 8086 processor. Okay, which is many times slower than a 486. I remember the early days of programming. I remember when I was in high school. Okay, technology has changed so much. You know, I remember working on a what they called a dummy terminal, where the dummy terminal communicated to a computer on the other side of the street, where they had the VOTEC, and I was in a high school, and I was in 10th grade, and I would write a program in HP 9000 Basic. This was more primitive than the first version of GW Basic. It was more primitive than Turtle Basic. It was so primitive that you didn't really have true multi-dimensional arrays. Pretty much. I mean, you sort of did, but not really. I'm not going to get into the details of it. I mean, it was really primitive, basic. You know, when I had a Tristos 80 Model 3 computer, that was even less powerful than an 8086, but it had a more advanced version of basic than the basic I was using in high school. And I got that thing to do. I would have it, and it was a monochrome monitor, but I still was able to get it to create random forests and things like that. I wrote a computer program, and I coded up in BASIC. It requires a lot of math, and it had to do the math right. Okay, it doesn't take a lot. The like if you have a computer, I don't know. I'm getting into too many unnecessary details, but I'm baffled by why it is. You can't. There's really pretty much no limit to how complex a mathematical formula can be that a large language model should get completely accurate. And not because it's a large language model. There should have a front end module, and that should take an insignificant amount of computing power to perform even the most complex math formulas. Within reason, I mean, we can get creative and come up with ideas that not even a quantum computer in the vast future could solve. But what most people would think of normally, there's no reason why there should be a limitation in these models, and it's counterproductive to not have it. And if the excuse is like if you can't have a front end module also somehow communicate, so like a lot of math, like if there's nothing ambiguous about it, it should go straight through the front end module and never reach the neural network. But there should be circumstances where it might need to go through the neural network because you're involving more complex language, in which case there might be a greater risk for it to make an error or misinterpret your query. And maybe even in some respects, it might even in some cases get the math wrong if you're talking not multiplying two four decimal digit numbers together. I mean, but if we already know that large language models hallucinate, why would we use that as an excuse to not also, in addition to having anything that can just pass through the front end module without ever having to touch the neural network, also allow it to communicate with the neural network, so that you have a hybrid between the the math module and the neural network. It's not a big deal, And in that case, once your input reaches the neural network, then there is the potential for more mystery or unpredictability, where it might in fact somehow not fully comprehend what you're doing. But it would be way more useful, and it makes no sense at all that we have this situation. And even the Chinese company, I downloaded DeepSeek, right, and ran that thing, right. And even they didn't have it right. Even DeepSeek didn't do it right. It's like, come on, what's so hard about math? I mean, for a computer. Okay, I can't compute logarithms in my head. I can't. I can't multiply two four decimal digit numbers together without using pencil and paper if I don't have access to a calculator or a computer. I might be able to do it, but there's about 50% chance I'll get it wrong, and it probably takes me a minute to do it. And that's probably better than most humans, which is sad. Okay, but there's no reason why a computer can't do it. And there's no reason to say, well, because we're using a large language model, it has to be like that. No, it doesn't. And even for very large, complex math questions, even if you're plugging in derivatives and using higher math operations, I don't know what people any more think higher math is. You can have extended precision, you can have unlimited precision if that matters to you. But if you want to solve any useful or practical problems, these large language models would be actually much more useful for a lot of applications if somebody engineered intelligently a math module into a large language model. It makes no sense that you don't see more of it, especially when they want to talk about how much money they dump into this. Some of these large language models, they spent billions of dollars training this stuff. I mean, you can get computers to manipulate algebraic equations. Well, going all the way back to 1956 on the Joniac computer, which I can't find a historical record about how much computing power it has. Needless to say, this was probably like a billion times less powerful than the most powerful desktop computer of today. Yes, a billion times less powerful. Maybe not, but probably so. And I'm talking about the most powerful desktop computer, especially even if you compare it to the GPU. I mean, not the CPU. And the GPU, it might be like 10 or 20 billion times more powerful, literally. A desktop computer. But with way less experience and way less knowledge in artificial intelligence, the very beginning, really pretty much for all practical purposes, the actually first ever kind of AI program ever written. Technically speaking, it's not, but we go back farther and we're talking about hardware programs instead of software programs. And well, I'm not going to get into that. There was the perceptron that was developed in the late 1940s. I'm not going to get into that. That logic theorist was pretty much the first AI program out there, pretty much. And it discovered shorter proofs to logic theorems. Logic is supposed to, mathematical logic is something that most people don't know in math. That's considered a higher math. But in the 1950s, AI was already successfully and correctly outperforming human beings in some respects with math in the 1950s. Of course, they could not, so they weren't just better at arithmetic and performing math problems, or even punching in mathematical formulas, or even solving formulas that had dedicated subroutines that perform certain types of integral problems or using derivatives. No, I mean, these things were discovering solutions to problems that were actually better than human beings. There was only two theorems where it found a shorter proof than what human mathematicians found in the 1950s. But fast forward to the year 2025, I'm supposed to pretend that we can't incorporate these things properly into a large language model. Because again, yes, it is useful. No, it doesn't make sense to say, well, we don't need to because we have calculators and spreadsheets anyway. And no, we don't have to. And no, we don't have to allow a neural network to goof it all up. Okay. Human beings make mistakes, but we have a tendency to not, when we use calculators, we have a tendency to copy the information and to not scramble it up most of the time. Most of the time, if you're like that as a clerk, okay, and you have a calculator, but you're going to mess it up all the time, you're not going to record things properly. That's pretty sad. And we don't. There is not a reason why we have to have that kind of a problem with a large language model. And let's be honest, most large language models probably have more subroutines in it than just a neural network. It probably has some modules in it besides a mere neural network. Anyway, thanks for listening.